Today we'll look at combinations where there's an arbitrary number of categories. So recall that we had this problem where there were 18 members of a club and the executive committee had 3 members and the sporting committee had 5 members. And we calculated the different pairs of these committees using the number of combinations of executive committees multiplied by the number of combinations of sporting committees using the multiplication rule. So in this case, we assume that a person can be on both committees. So effectively what this looks like in the following notation. So that's n factorial on n minus r1 factorial multiplied by r1 factorial, and that's multiplied by n factorial on n minus r2 factorial by r2 factorial. Now if no person can be on both committees, then we need to subtract the number of people already allocated to the executive committee from the second combination. So given that 3 members were allocated to the executive committee, then we subtract this from the number of members. So therefore this becomes 19 factorial. And then n minus r2 factorial will be 19 minus 5, which gives 14 factorial. And that's multiplied by r2 factorial. So this here gets replaced with 19. So we're choosing the executive committee in the following number of ways, and then the sporting committee from the remaining 19 members in this number of ways. And cancelling out the 19 factorials, we can write this as n factorial on r1 factorial by 14 factorial by r2 factorial. Now if we want to distribute all 18 members in 3 categories, so we initially have 22 members distributed in the first category, being the executive committee, and the remaining 19 members get distributed in the sporting committee. So we have 14 members left, and I'm going to distribute the remaining members in a third category. So that equals the 22 factorial on 19 factorial by 3 factorial, and then we have 19 factorial on 14 factorial by 5 factorial, and then we have 14 factorial on 14 minus 14 factorial multiplied by 14 factorial. So as we can see, the 19 factorials cancel, and the 14 factorials cancel, and 0 factorial is 1. So we end up with n factorial on r1 factorial by r2 factorial by r3 factorial. So in shorthand notation, we write this as n, r1, r2, r3. So we can say that r1 plus r2 plus r3 is equal to n. So more generally, to distribute all elements n in multiple categories, then we have n from r1, r2 up to rk, which is equal to n factorial on r1 factorial by r2 factorial, and so on by rk factorial. So this is the number of ways of putting n distinct objects into k categories. So r1 goes in category 1, r2 goes in category 2, and rk goes in category k. Noting that the sum of r1 to rk is equal to n, where we've allocated all the members to those categories.